In this video, we're going to look how to calculate power. So here are our formulas for power. So it's basically the amount of work that you do and in the time that you do it. So we need to do our energy divided by our time in seconds. So we want joules and we want seconds for our unit. So in this example here, we have a standard incandescent light bulb with a wattage rating of 100 watts. So that is our power, and that means that we can also replace it with joules per second. And we have our time, we have 1 minute. 1 minute is 60 seconds. So here's our formula. And if we want to rearrange to get E, we'd be multiplying both sides by T. And then we can just put our information in. So joules per second times 60 seconds. So that gets us 6,000 joules or 6 kilojoules. And we do only want one significant digit because our 1 minute has 1. So that's just a basic, again, one more like a multiple choice type question. This one's a little bit trickier, so we have a mass. So let's write down what we know. 70 kilogram student climbs to the second floor of the school, which is 4.2 meters above the first floor. And we have a time of 6.1 seconds. So what is his power? So power is equal to our energy over our time. So in this case, we don't have our energy, but we're given mass and our height. So that means that we're going to have to solve for our potential energy. So I'm just going to sub in mgh for my E and then keep my T. And so we can go ahead and just put our information in. And so we get 472 watts. We want to round to just two significant digits because of our 6.1 and our 4.2. So let's go ahead and round that down to 470 watts. So that's all you have to do. So sometimes you have to calculate your energy, sometimes you're already given the energy. So the next part of the lesson deals with our EnerGuide ratings, and these are stickers that can be found on appliances. So when you're going shopping, you can actually see how much energy an appliance would use on average for an average family. And so then you can figure out how much it would cost to run that appliance. So energy ratings we usually have in kilowatt hours. So rather than having watts, we have kilowatts, so there are 1,000 watts in a kilowatt. And rather than seconds, we're using hours, because oftentimes when we're running appliances, we're not running them for seconds, we're running them for hours. Before we look at our next example, we need to look at our time of use costs. So these are the costs as of May 1st, 2016. So we need to know when we are running our appliances that they cost different amounts of money. So most of you told me today in class that your parents make you do your laundry or anything like that after 7 o'clock at night. And that's because that's our off-peak time. And so off-peak time is our cheapest time of day to run our appliances. When we're running things on peak, it costs quite a bit more. So you can see there's a 10-cent difference almost there. So what we're going to do is we're going to look at an example where we're going to count how much it costs to run some lighting in our classroom. So let's write down what we can see. So we have a fluorescent lighting tube uses 23 watts. So when we're doing these cost calculations, we need it to be in kilowatts. So we're going to divide that by 1,000 to get kilowatts. And all the tubes, just so you know, so you're not in our class obviously, but we have 48 tubes. We counted them today in class. So we have our time, 6.5 hours, and we're going to run them for 5 days a week. And then we want to also calculate it for how much would it cost for 188 days. So there's no real formula when we're doing this, but basically what you're going to do is you're going to take your power, your kilowatts, you're going to multiply it by your cost. And to use the cost, we're going to use the average between mid-peak and high peak, because that's usually when we're at school. So we're going to take our 15.6 cents per kilowatt hour. We're going to multiply it by our time, 6.5 hours, and then we're going to multiply it by 48 because that's how many tubes we have. The other alternative would be to multiply your wattage by 48 and you could be solving it there. So you can see that kilowatts cancel, and hours cancel. So we're going to be left with units of cents. So go ahead and type that in on your calculator. So it's 111.95 cents. Okay? And so that would be for one day, because that's our 6.5 hours. Let's go ahead and convert that to dollars, because that's often what we deal with. So it's $1, and 12 cents per day. And so 1 week, 5 days of school, we would do our 112 times 5. So we get $5.60. So it would cost $5.60 for 1 week. A whole year, 188 days, we're going to do $1.12 times 188. So that's $210.56, which may not seem like a ton of money, but think, that's one classroom. How many classrooms are in the school? Is everybody leaving the lights on all the time? That cost can add up really fast. And so we can save money and energy and the environment just by turning off the lights.